Hello. So in this video we're going to look at how to find precise t multipliers. Usually I just use the t multiplier, the t table, but sometimes in some of these software programs they kind of expect you to be a little bit more precise, so that's why we're going over this. Alright, so first let me just remind you, when is it that you actually need to use t multipliers? Well, you basically use them only when you're computing a confidence interval. All right, and let me just remind you, if you're doing a hypothesis test, you're going to use TCDF, and then you're going to put in the first t-score, the second t-score, and then the degrees of freedom. When you put in the degrees of freedom, your calculator knows now which t-distribution to use, so you don't have to mess with anything else. So when is it that you need to mess with the table, or in this case, find the t-multiplier? When you're finding a confidence interval, all right? And we're only looking here at confidence intervals of numerical traits, all right? That's why the t-table got complicated. All right, so what do you use? You're gonna use INVt, and where do you find it? In the same place you found INVnorm, or normal CDF, or TCDF, same location. Find by pressing second distribution to access vars, and then scroll down and find it. Because there's several different versions of the TI, I don't know which number you scroll down to, okay? But we're going to go through it. All right, so let's say here, if I were using the t-table, right? So here I'm using the t-table, and I was asked, find a 95% confidence interval where the sample size is 32. So you basically would look up here 95%, and then you find your degrees of freedom, which would be 31, but you can't find it. 31 is between 30 and 32, so you use the more conservative value here, 2.042. Right? Let me see if you guys can see that. Yeah, you can. Okay, so that's what you do, and there's a couple ways to look it up. You could either look it up as 0.025 at the top, right? So it's here, 0.025 at the top, or 95 at the bottom, which is what I always use. I just find it a little easier. But I just want to kind of show you this because when you go to use the calculator, you're going to have to take the leftover area, the 5%, and divide it by 2. So that's what they're doing here. All right. All right, so that's how you do this using the t-table, and you get 2.042. But let's say instead you're going to do this more precisely, and now you're going to say, hey, I'm going to use the calculator. So you're going to use INVt, and you need to find the area to the left of that particular confidence interval you're using. And then you also need to you find the degrees of freedom. So the area to the left, if it's a 95% confidence interval, leaves you 2.5% of the values on either side, right? So here's the 95%, and then you have 2.5% here and 2.5% here. So where you want to be is here. So you actually want to have 97.5% to your left, right? So you're going to use 0.975. I'm going to use a decimal form. But just remember that when you're using INVt, you've got to find not just whatever the confidence interval is, but you have to find the total area to your left. All right, so you're going to have to find your leftover area. 100 minus 95 is 5%. That gets split equally, so 2.5% here, 2.5% there. So you add your 2.5% plus the 95%, gives you your 97.5%. So therefore now, when you're going to use your INVt, you're going to input the area to the left, a comma, and the degrees of freedom. All right, so we have 32 is the sample size, degrees of freedom is 31. When you put that in, you should get 2.03951. Let's go ahead and do it. All right, I'm going to go to second distribution to access vars. In my case, INVt is number 4. There we are. So I'm going to pick that. And now I'm going to put 0.975, comma, 31. And it thinks a little, 2.03951. So 2.03951, all right? Now, if you look at your t-table, let me just show you that we found 31 degrees of freedom because it wasn't there. Notice 2.037 and 2.042 basically on either side of 2.03951. So 2.03951 would be right in the middle of that, right in there. All right, so now that you've got your T multiplier, let's just do a quick example to see how you'd use it. If you were asked, find a 95% confidence interval for the weight of the bags of chips in a given sample of 32 bags that had an average weight of 8.06 ounces and a sample standard deviation of 0.03. Notice the trait is weight, which is a numerical trait, and I'm being asked to find a confidence interval. So here you go. Here's your info box, right? The Y bar, or sample mean, is 8.06. That's the average of all the weights of all 32 bags. S is the standard deviation of the weights of all the 32 bags, and then your sample size is 32. So now for any confidence interval, you start out with a sample estimate, add or subtract a margin of error. And so now I'm just filling this in with the precise t value, and these are the values you'd get. You can just pause and verify that if you'd like. And then finally, when you go to interpret it, you'd say with a 95% confidence, don't say confidence interval, it's the confidence. With a 95% confidence, the average weight of all bags of chips is between, and you give them the values, 8.04918 ounces and 8.07082 ounces. Now notice what we did here is we estimated the true mean, and the mean of all bags, right? That's what we're estimating is mu with a 95% confidence. All right, thank you so much for listening.